Hi, Assalamualaikum. In this video, we would like to share about interpolation. We are from Group 3. A special thanks to our lecturer, professional technologist Dr. Ain Binti Nazari. This is our content which contain 5 topics, which is group members, introduction, methodology, discussion, and conclusion. This is my group members, include Sharvina, me, and Faiz. So we move to introduction. Long-range interpolation is a method for determining an approximation of mathematical statement by using any intermediate value for the independent variable. The fundamental purpose of interpolation is to determine what extra data exists outside of the data has been obtained. When interpolating several data sets on the same data points, Lagrange form is more efficient. This formula is used to determine the function's value even when the parameters are not evenly spaced.
My name is Sharvina. Next, I will be continuing with methodology. So, based on the global cumulative installed wind capacity from the year 2000 to 2015, as shown in the figure 1 below, the polynomial can be evaluated to estimate the corresponding value, which is the cumulative installed wind capacity in the year 2012. So, we got this data from an article through in internet. So, this is the article. So the article's title is Wind Turbine Current Status Obstacles, Trends and Technology, and this is the data that I showed in the slide just now. So this is the global cumulative installed wind capacity from the year 2000 and 2000 to 2015. So this is the data that we are going to use throughout this project, and this data is obtained from the Global Wind Energy Council. So in our project, we are not going to use the whole data like from 2000 to 2015. We are only going to use from 2008 to 2013 as shown in the picture at the right hand side below. So we are going to only use 5 years, and the year that we are going to find the value is the year 2012. So there are two different numerical methods to find to solve this problem. So the first method is Lagrange interpolation. Lagrange interpolation has 4 types of approximation, which is linear approximation, quadratic, cubic, and quartic. And for method 2 is Newton divided difference. The first one is first Newton divided difference, second, third, and fourth. And for the next one is discussion. So for Lagrange interpolation, the first type of approximation is linear approximation. So the left hand side picture shows the manual calculation, and the right hand side picture shows the MATLAB simulation coding. As for the manual calculation, for linear approximation, it involves 2 points. So the years is represent the points. So so X is 2011 and 2013, which represent the year. So in the previous slide, for linear approximation, we are going to take from the extreme right towards the left. So the extreme right is 2013, and before that is 2011. So because linear approximation involves only 2 points, so using the formula for linear approximation, the answer that we have got is 278,273.5. And as for the MATLAB coding, the answer that we have got is 278,273.5. Okay, so now I will show the MATLAB coding through the software. So this is the coding for the linear approximation. So first we have to define the data points. So first you have to declare the values. So X value will represent the years, which is from 2008 to 2013. Actually, for X value, we can either put everything, all the years, or we can only mention the year 2011 and 2013, because it's going to give the same answer at the end. And for Y is corresponding value for each years, the cumulative installed wind capacity for each year. So according to the data from the article, for 2008 the value is 1206690, for 2009 and is 159016, and so on. And then next we have to evaluate the polynomial at x equals to 1. and then y interpolation equals to interpolation x. X actually represent the vector x contains sample points, and y is the vector y is the contains the corresponding value for the years. And then is 2012. 2012 is the year that we are going to find the cumulative installed wind capacity. And then is we have to state that this is a linear approximation, so that the MATLAB will calculate the answer for linear approximation. And then next we have to display the interpolated value. So how we are going to display is by typing this DISP, and then in bracket interpolated value at x equals to 1. Number 2 str means string, so it actually converts the numeric array into a characteristic array that represent numbers. And then finally after that that coding, it will finally display the final value, which is x is equals to 278,273.5. so that is the value for linear approximation, which is the same as the manual calculation value. Okay, so for the second one is the quadratic approximation for Lagrange interpolation. So for quadratic approximation, it involves 3 points. So we will choose the year 2010, 11 and 13. So using the formula for quadratic approximation, the answer that we have got is 278,259.6667. And at the right hand side, it shows the MATLAB coding for quadratic approximation, and the value that we have obtained is 278,259.6667, which is the same as the manual calculation. And now I'll be showing the MATLAB software that we have used to obtain the answer for MATLAB simulation. So first we have to define the data points. So for quadratic approximation, it involves 3 points. So like for x is 2010, 11 and 2013, and y is the corresponding value for each year. And then we have to perform the interpolation. So y underscore interpolation equals to interpolate x, y and 2012, because we are going to find the value at 2012. And then is SP line. Previously for linear approximation, we have used the word linear. For quadratic approximation, we are using SP line because it's the interpolation by cubic, so it involves 3 points. And then we'll have to display the interpolated value. So we have to type this DISP in bracket interpolated value at x equals to 2012, and then number 2 string y underscore interpolation, and finally it will display the interpolated value, which is 278,259.6667. so this is the MATLAB coding, and then it is also the same as the manual calculation. So that is all from me. Thank you.
My part, I've been taking cubic approximation. So what's the difference between quadratic and cubic is only add one more data from the table given. So as we can see here, the manual calculation, by following this formula given, we can substitute everything, and lastly we'll get 278,556, which is the last answer. And this is MATLAB command. It is very simple. We only put the data in, which is the year 2009 to 2013, and the value of y, which is 4 point, and SP line written there is the function of MATLAB tools, which can count for cubic approximation. And lastly, as you can see, 278,556. Going back to 278,556, which is exactly same manual and MATLAB. For the quadratic, we got here 5 points, which is also the same, only different formula we need to substitute. And lastly, we get 278,855.6. We straight go to the add command, which is this quite different than before. We put in the data of year, which is X, and the data of Y, which is the value of Y. And then, as we can see, the long equation here should be the formula, which is will result or will display the same value as what manual calculation does. So this is, the green color is showing us the function of each command. Lastly, it will display the value of Lagrange interpolation by using quantity approximation at 2012, which is 278,855.6. That's all from me. I'll pass the next slide to Faiz.
Okay, thank you Nasruddin for the Lagrange interpolation. Okay, my name is Muhammad Faiz bin Bahrun. I'm going to explain about Newton divide difference. Formula for Newton divide difference, it might be difference from Lagrange interpolation. For Newton divide difference, we have to use a long table to find Fi naught, Fi1, Fi2, Fi3 and Fi4. Each one have their own formula. So firstly, we have to calculate first Newton divide difference, second Newton divide difference, third Newton divide difference, and fourth Newton divide difference. And the last one for manual calculation, we have to find the function of x at 2012. So the final value for the manual calculation might be 278855.6008. We have to declare the data given from the question: X 2008, 2009, 2010, 2011 and 2013. So same as Y, we just take from the question. We have to declare the number of data, initialize the divide difference table, display the divide difference table by using the DSP divide difference table, DSPF. So underscore interpolation 2012, Y interpolation F11. So for the last, the display table for the interpolation might be like this, and then the interpolated value at X 2012 might be 278855.6, same as the manual calculation. And then we display the divide difference table, DSP divide difference table, by using this coding. So for the Newton divide difference interpolation, X interpolation at 2012 and Y interpolation at F11. So we can display the interpolation using this coding, num string Y interpolation. So for the simulation, we can just copy the coding and to command window and paste. So for simulation, we just can enter. So the display show that interpolation table at X 2012, num string interpolation, and the final value for X 2012 is 278855.6. So that's all. So for conclusion, in order to estimate data points, we investigate two interpolation techniques. First one is Lagrange interpolation, and the second one is Newton divide difference. Lagrange demonstrate exceptional adaptability by building polynomial that could accommodate data that was equally or unevenly spaced. Conversely, polynomial coefficients were calculated using a difference table in Newton method. MATLAB was used to confirm the accuracy and precision of our manual calculation, guaranteeing consistency between the outcome of the two methods. The application of this interpolation technique to the real problem solving setting demonstrates their practical success.